This is page 3, top of page 3 of our notes. We're solving for kinetic energy. That problem is at the very bottom of page 2. Yep, okay, great. Okay, cool. We're solving kinetic energy. So it says, solve each problem using KE equals 1/2 mv squared. So this is the formula that we're gonna keep using for all of these problems. It says, show all of your work. That's important, okay? Make sure you show your work, just like what you do in math class. Okay, so it says, calculate the kinetic energy in the following systems. A car with a mass of 1,200 kilograms is traveling 18 meters per second. So it says the mass is 1,200 kilograms. So M equals 1,200 kilograms, and that's the right units for mass, so that's good. And then at 18 meters per second, is that going to be my kinetic energy or my velocity? Good, that's going to be my velocity. Okay, so I know my M and my V, I just need to solve for KE. So my formula was KE equals 1/2 mv squared. So I'm going to use that formula, but I'm going to put M, I'm going to put M as the 1,200 kilograms. And I'm going to put 18 meters per second as my V. And I need to make sure I square that. So now I just need to type this into a calculator. Or use my mental math skills. Half of 1,200 is 600, right? And 6 times 18 is the same as 12 times 9. What's 12 times 9? That's 99,108. So this is, yeah, I think so. And then I took away the 2 zeros, so I have to add those in. Is it 10,800 or 108,000? Is it? Okay. I think I needed to add 2 zeros. I think it's 1,000. I should probably type that in. I took away 2 zeros and now I'm confused. I'll type it in. I tried to do the mental math. Did anyone type that in? Oh, you know what? I forgot to square it anyways, so I need to fix that. I shouldn't have tried to mental math it. Don't write the 10,800 because I forgot to square it. Okay, let me type this into my calculator. Which I have a bunch of calculators up by the door if you like handheld calculators, or you can type it all in at once on Desmos, that's fine. Okay, so if I type that in, I'm gonna do 1/2, which is the same as 0.5, times 1,200. And then since the 18 is squared, I'm gonna multiply by it twice on this calculator because it's hard to type that in. Times 18 times 18. You can flip your calculator sideways and have it have the squared button. Yeah, okay. I forgot the extra 18. So 194,400. I still didn't write it right. Oh my gosh. I haven't had enough coffee this morning, you guys, sorry. Probably better off doing them without me. Okay, and we said the units for our energy are gonna be joules. So that's gonna be J. Okay, so that's that kinetic energy, and I think they wanted us to write it over here too, but as long as you've got it here, that's what you're trying to solve for, you're okay. Okay. If you know what you're doing and you don't need me, feel free to work without me. If you think you'd go faster, like, by all means, do that. Okay, so let's do this again. And if you can't see it back there because I haven't zoomed in, just yell at me and tell me to zoom in. Why is this not zooming? Oh, because I'm doing the wrong thing. Okay, yeah. If you can't see it and you need me to zoom, just yell at me. Okay. B, a car with a mass of 1,200 kilograms. So we know our mass is 1,200 kilograms, is traveling at 100 meters per second. So our velocity is 100 meters per second. Okay, so we're gonna use that same formula to find kinetic energy. So kinetic energy equals 1/2. Mass was 1,200 kilograms, and that's the correct units for mass, so that's good. And then times velocity squared. Velocity was 100 meters per second. And we have to make sure we square that. Yeah, so we have to make sure if you're doing it in a calculator that doesn't do squared, make sure you type it in twice or hit squared. Is it? My half of 1,200 is 600, right? And then 100 times 100 is gonna be 1 with 4 zeros. So 10,000, I was gonna say, I'm just gonna type it in. 600, it's gonna be a lot of zeros. 6 with a lot of zeros, okay. Half is 0.5 times 1,200 times 100 times 100. Okay, yeah, okay. It's a lot of zeros. 6 million. It's gonna be 6 million. So our kinetic energy is 6 million. If you guys see I'm making a math mistake, yell at me. 6 million joules. Okay, let's do another one. And again, if you don't need me, feel free to go ahead and work ahead. And I always have calculators up by the door. They're in that little white thing. A car with a mass of 1,200 kilograms. That's probably pretty accurate for a car. Is traveling at 5 meters per second. That's my velocity then, right? That's my speed. And I just need to plug the right stuff in the right places then. That's our kinetic energy, which is our moving energy, right? The energy that we have from our movement. So kinetic energy is 1/2 times 1,200 kilograms times our velocity squared, which is now 5 meters per second squared. Okay, so 600 times 5. I can do this, right? 6 times 5 is 30 plus 2 zeros. This is gonna be 30 plus 2 zeros. That's gonna be 3,000. I'm gonna type it in just to double check, but I'm pretty sure I did that right. Let me type it in really quick. 0.5 times 1,200. Oh no, I didn't square the 5. I keep not squaring the 5. Yeah, I didn't square the 5. Sorry, you guys. This is gonna be 15,000. Don't trust me. I keep forgetting the squared, which is what you guys will do too. You'll forget the squared when you do them on your own. Unfortunately, that's the most common mistake. Okay. And that's a measure of energy, so that's gonna be in joules. Okay. Fantastic. Okay, here's the deal. If we have time, I'll keep working through those, but I'm gonna pause really quick. I wanna do one off the back too to make sure you guys see one like that. Okay. So on the back then, I'll do a few of those and then we'll keep working through these until the bell rings. So the back is, instead of kinetic energy, it's gravitational potential energy. So that's this other formula. You still just put the right stuff in the right places for that, okay? So solve each problem using this formula, show all of your work, calculate the gravitational potential energy in the following system. A car with a mass of 1,200 kilograms is at the top of a 42-meter hill. That's gonna be, the height is 42 meters. We're using the 10 meters per second squared for our gravity. So we just have to plug that into our formula. They can't decide if they're gonna make an announcement or not. So our formula is mass times gravity times height. Mass was 1,200 kilograms. Gravity is that constant 10 meters per second squared. and they said our height was 42 meters. So we just have to type that into our calculator. Okay, when we type that in, we should get 1,200 times 10 times 42. 504,000. And again, this is a measure of energy, so this is gonna be in joules. Okay, it's gonna be in joules. So same concept though. You pull out the important information, figure out what it is, plug it in the right places, type in your stuff. Some of them, you might have to like solve for the variable instead. That's like, I think probably the hardest part is if you struggle with algebra. But especially these ones at the top, you should be okay. Let's do another one. A 65 kilogram climber on the top of Mount Everest. Mount Everest is 8,800 meters high. So 65 kilograms. Is that my potential energy, mass, or height? Good, that's gonna be my mass. We can tell by those units. And it's 8,800 meters high, so it tells us that that's the height. That's really tall. Okay, and we're trying to find the potential energy. So we're gonna use that same formula. Potential energy is mass, which is 65 kilograms, times our gravity, which is 10 meters per second squared, times our height, which is 8,800 meters. Okay, and then we just type that in. 65 times 10 times 8,800. That's gonna be, that's a big number. I did type that in right though, okay. That's gonna be 5,720,000. And that's energy, so that's gonna be in joules for potential energy. Cool. I'm gonna skip C because that one should be okay for you guys. I'm gonna do one of them where you have to do like the algebra and solve for it. So I'm gonna go ahead and do number 2 with you really quick. You guys still should do C without me at some point. A diver has a 3,400 joules of gravitational potential energy. So 3,400 joules is our potential energy after stepping onto a diving platform that's 6 meters above water. So the height is 6 meters. It says, what is the diver's mass? So we're solving for M. So we're still gonna use that potential energy formula, but we're gonna plug in the right stuff in the right places. So I'm gonna put 3,400 joules as my potential energy on the left. And then I'm gonna put my mass as a variable because I don't know it, times gravity, which is 10 meters per second squared, times my height, which we said was 6 meters. Okay, what's 10 times 6? Good, that's 60. So I'll end up with mass times 60 meters squared per second squared. Oop. Let's finish this and then you guys can pack up. How do I undo multiplying by 60? Good, I'm gonna divide both sides by that 60 then. Okay, and when I do that, I'll end up with, I'm gonna go over here. My mass is equal to 3,400 divided by 60. That's 56.7. Okay, and mass is measured in kilograms for this. So 56.7 kilograms. Okay, that's your pack up alarm.